If you have a denominator that is some number plus a square root, you would multiply by the conjugate, some number minus the square root, in order to get rid of the radical in the denominator. To get rid of a radical in the denominator, when you have an addition or subtraction expression, you must multiply by the conjugate. So in number 7, our denominator says 1 minus the square root of 5, and we can't have the square root of 5 in the bottom. But because it's 1 minus the square root of 5, we can't just multiply by the square root of 5 and make that go away, because we'd have to distribute it to the 1, and then we'd be stuck with another square root in the bottom. So the trick is to multiply by the conjugate. The conjugate is exactly the same as the denominator, but change whatever symbol is between the number and the square root, change that symbol to the opposite. So if it's 1 minus the square root of 5, we are going to multiply by 1 plus the square root of 5. If it had been 1 plus the square root of 5, we would have multiplied by 1 minus the square root of 5. So the conjugate is switch the sign. If you multiply the denominator by something, you must also multiply the numerator by that same thing. In the numerator, we are going to distribute. 1 times 1 is 1. 1 times the square root of 5 is 1 times the square root of 5. You don't have to write the 1 in front of the square root, but it's often a good idea to. In our denominator, we need to double distribute. So start by distributing the 1. 1 times 1 is 1. 1 times the square root of 5 is 1 times the square root of 5. Now we distribute the negative square root of 5. Negative square root of 5 times 1 is negative 1 square root of 5. Negative square root of 5 times positive square root of 5. Because it's negative times positive, it's minus. Square root of 5 times square root of 5 is the square root of 5 squared. Okay, now let's think about what is in this denominator. First, look at the square root of 5 squared. The square root and the square cancel each other out, so this is simply 5. 1 square root of 5 minus 1 square root of 5, those two terms are identical but opposite, so they cancel each other out. Do you notice that the square roots all canceled each other out? So what's left in our denominator? We've got 1 minus 5. So we have 1 plus 1 times the square root of 5 over negative 4. Okay, but a little bit of bad news. We can't leave a negative on the bottom either. That's just not good. But we can multiply everything by negative 1. So this would become negative 1 minus 1 times the square root of 5. You don't need the 1 in front of the square root, but you can certainly write it over positive 4. So just flip those negatives around. I would like you to try to start number 8 on your own. Now, to get you started, our denominator says 2 minus the square root of 6. What is the conjugate of 2 minus the square root of 6? 2 plus the square root of 6. If it had been 2 plus the square root of 6, then you would multiply by 2 minus the square root of 6. So we are going to multiply by the conjugate 2 plus the square root of 6. And whatever we multiply to the denominator, we have to also multiply to the numerator. In the numerator, 6 times 2 is 12. 6 times the square root of 6. 6 is a whole number. The square root of 6 is a radical, so we can't actually combine them. We can just smush them together into 6 times the square root of 6. In our denominator, 2 times 2 is 4. 2 times the square root of 6 is 2 times the square root of 6. when you distribute the negative square root of 6, negative square root of 6 times 2 is negative 2 square root of 6. Negative square root of 6 times positive square root of 6 is negative square root of 6 squared. The square root of 6 squared becomes plain old ordinary 6. 2 square root of 6 minus 2 square root of 6 is 0. So we have 4 minus 6 in our denominator. So 12 plus 6 times the square root of 6 over negative 2. Problem number 1, we have a negative in the bottom, so we need to divide everything by negative something. But I also want you to check your whole number pieces. Check the 12, 6, and the negative 2. Your whole number pieces are the pieces that aren't under the square root. Do those whole number pieces have anything in common? You can divide all of them by 2, which would get rid of that 2 on the bottom, which would further simplify your problem. But because there's a negative on the bottom, we're going to divide everything by negative 2. So 12 divided by negative 2 is negative 6. 6 divided by negative 2 is minus 3, and we still have that square root of 6. A question was just brought up. What if you add the 12 and the 6 to make 18, and then do 18 divided by negative 2 to get negative 9? The problem is, what's happening between the 6 and the square root of 6? Multiply. And according to PEMDAS, can you add when there's multiplication in front of it? No. So because 6 times the square root of 6, you would have to do that multiplication before you'd be allowed to add 12. So no, you cannot add the 12 and the 6. That's a really, really good question because that's a mistake that a lot of people try to make. So don't do that. PEMDAS says no. Okay, turn the page. Let's look at adding like expressions. Before we start number 1 here, I have a question for you. What is 5x minus 3x? 2x. You all agree that 5x minus 3x is 2x. Okay. That's basically what we're doing. Do you see that 4 raised to the 3/4 is the same as 4 raised to the 3/4? So think of this 4 raised to the 3/4 like it's an x, or say a snickerdoodle cookie. We have 5 snickerdoodle cookies minus 3 snickerdoodle cookies. So how many snickerdoodle cookies do we have? 2. So 2 times 4 raised to the 3/4. If you think of it as this is an x and this is an x, it's easy to see that our answer is 2 of whatever those things are. So as long as the base matches, so it's both 4, and the exponent matches, you can add or subtract the coefficients in front of that term. So try number 2 on your own. All right, this one's a chocolate chip cookie. So 6 chocolate chip cookies plus 4 chocolate chip cookies is 10 chocolate chip cookies. 10 times 3 raised to the 2/3. Before we get to number 3, I would like to include example A right here. If I have 5 times the 3rd root of 2 plus 4 times the 3rd root of 2. Do you see how the index is the same on both of these? And the radicand is the same on both of these. So we have 5 third roots of 2 plus 4 third roots of 2. So how many third roots of 2 do we have altogether? 9 third roots of 2. if you think about it in terms of x, basically this is 5x plus 4x, which is 9x. The x just happens to be the third root of 2. So our answer here is 9 times the third root of 2. Now let's go to example 3. That's what we're trying to do, is add our like radicals. Notice the index is the same. Is the radicand the same? No, so we can't currently add these. But using what we learned yesterday, we could simplify the cube root of 81. Look in your thirds column. See if you can find any number smaller than 81 that we could split 81 into. 27. And here's a really, really big hint. You want to be able to subtract a third root of 3. So it'd be really nice if this was a third root of 3. That can help you to figure out that 27 is your other number, because 81 divided by 3 is 27. The third root of 27 is 3. So we have 3 times the third root of 3 minus the third root of 3. Now, there's no coefficient here. It's a 1. It may be helpful to write that 1 in so that you don't do this math incorrectly. So 3 somethings minus 1 somethings is how many somethings? 2 somethings. That something is just the third root of 3. Try number 4 on your own. You're going to first need to simplify the cube root of 625. And then do the requested subtraction. So to simplify the cube root of 625, we want to break it into the cube root of something in our thirds column times the cube root of whatever number it takes, so that those two things multiply to give you 625. You can either start by looking in your thirds column at like approximately half of 625 is 300-ish, so start around there. So you could try 216, that would be a decimal. 625 divided by 216 is a decimal. 625 divided by 125, that gives you a whole number 5. Or, shortcut, you're trying to subtract a third root of 5. So you really want this one to be the third root of 5. So try 625 divided by 5 and see if the resulting number is on your perfects chart. And ta-da, it is. The third root of 125 is 5. So we have 5 times the third root of 5. Those numbers will not always match like that. That's kind of a coincidence, the way that this notes packet worked out. Minus the third root of 5. So don't forget, what you're trying to do is this subtraction. So you simplified the cube root of 625, and now you're subtracting the third root of 5. Don't get confused. This is like 5x minus x. Our answer should be 4x. So 5 cube roots of 5 minus 1 cube root of 5 will give you 4 cube roots of 5. Your assignment is on page 248. Again, it's a popular page. Numbers 29 through 32 all. And then 37 through 45 odd. Oopsie.